So there's this new paper out of Stanford it's making some serious waves in the ML world. And honestly, for a really good reason. It's all about a new way to align AI models with what we humans actually want, but it's way simpler, more stable, and way more efficient. It's called direct preference optimization, or DPO for short. Let's get right into it.
Okay, so the entire paper, and really the whole idea, is built on this one kind of mind-bending quote. Your language model is secretly a reward model. Sounds like the title of a spy novel, right? So what on earth does that mean? Stick with me because we're going to break down that little secret and see why it could totally change the game for how we build AI.
All right, first things first, let's talk about the big picture. You've probably heard about the AI alignment problem. It's one of the biggest challenges we're facing. I mean, we've got these super powerful language models that have basically read the entire internet. But how do we actually get them to do what we want? To be helpful, to be safe, and not just spit out random, unhelpful, or even harmful stuff. That's the core problem we're trying to solve here.
So for a while now, the go-to answer for this has been something called RLHF. That stands for Reinforcement Learning from Human Feedback. You've definitely used models trained this way. It's the secret sauce behind a lot of the big names out there. It's powerful, for sure, and it's basically been the gold standard for getting AI to listen. But, and this is a big but, there's a catch. RLHF works, yeah, but man, it is a beast to handle. We're talking notoriously difficult, super complex, and often really unstable. Plus, it costs a fortune in compute time. This complexity? It's a huge wall that stops a lot of smaller teams and researchers from even trying. So why is it such a headache? Well, just look at the process. The classic RLHF pipeline is this clunky three-step dance. Step 1, you do some basic supervised fine-tuning. Okay, standard stuff. But then, step 2, you have to build and train a whole separate model, a reward model. Its entire job is just to look at 2 different AI responses and decide which one a human would like better. And then, for step 3, you take that reward model and use it to guide your main AI using these really complex reinforcement learning algorithms like PPO. It's a lot. So you see the problem, right? You're basically juggling all these different moving parts. You've got this complicated pipeline. That reinforcement learning part is super finicky and can just fall apart for no reason, and you're training and paying for at least 2 giant models instead of 1. It all adds up to a massive headache, both for the engineers and for the budget. And this is where our story takes a turn. The Stanford team looked at all that mess and came up with something just incredibly elegant. They call it direct preference optimization, DPO, and it's designed to just sidestep that entire complicated dance. So what exactly is DPO? Well, think of it as a super stable, really high-performing and lightweight way to get your AI aligned directly with what people want. And here's the magic trick. It does all this using a simple classification loss. That means it completely gets rid of the need for that extra reward model, and it throws that whole tricky reinforcement learning step right out the window. And this brings us back to that secret, right? Your language model is secretly a reward model. Here's how DPO cracks the code. The researchers figured out a clever mathematical trick to basically bake the reward function directly into the language model itself. The model learns the reward implicitly. So instead of a complicated reinforcement learning problem, it becomes a much, much simpler classification problem. All you have to do is tell it, hey, make the good answers more likely and make the bad answers less likely. That's it. It's brilliant. Okay, so let's put these two head to head. When you see them side by side, the difference is it's night and day. You can really see how clean the DPO approach is. This diagram just says it all, doesn't it? Over on the left, that's the old way, RLHF. You see the preference data feeding into a totally separate reward model. Then that reward model gets tangled up in that complex RL loop just to nudge the main AI. It's a whole contraption. But then, look at the right. That's DPO. It takes the exact same preference data and just directly updates the language model. One step, done. No extra model, no messy loop. It's just so much cleaner. So let's just recap that comparison real quick. RLHF, it's a multi-stage mess. You need a separate reward model, you're wrestling with these unstable RL algorithms. It's a pain. DPO, it's a single shot. No extra reward model needed. It just uses a simple, stable classification loss, which makes it a dream to implement and train by comparison. Okay, I get it. It's simpler, it's cleaner, it's more stable. That's all great. But here's the million-dollar question. Does it actually perform?
Can this elegant, simple thing really go toe-to-toe with a big, complicated industry standard? Well, the data's in.
And honestly, the results are pretty jaw-dropping. They put it to the test on a summarization task, and the models they trained with DPO actually had a higher win rate than the ones trained with the more complex PPO method. So DPO didn't just match the performance of the super complex RLHF method, it straight up beat it. 61%. Let that sink in. That number is so important because it proves DPO isn't just about making things easier. It's about making things easier and getting better results. It is the absolute classic case of getting more for less.
So let's wrap this up with the key takeaways. What does this all mean? Well, number one, DPO is way simpler. It just yanks entire stages out of the old alignment process. Number two, it's more stable, which means it's way easier to train. 3, it's more efficient, so it's cheaper and uses less compute. And maybe most importantly, number 4, the performance is top-notch, matching or even beating RLHF. What this means for everybody building AI is that aligning these powerful models is about to get a whole lot easier, cheaper, and more reliable.
And all of this really leads to one big question, doesn't it? When you look at how simple it is, how stable it is, and how well it performs, you have to ask, are we looking at the new standard for training AI? Is this the future of alignment? Only time will tell for sure, but DPO is making one heck of an argument. This is for entertainment purposes only.